Hello and good morning, everyone. It's so great to be here again. I'm sorry, my voice is a little bit lost right now. But yeah, it's so great. It's always good to be here over in America and always to share some of the things that we're doing and to gain some insights with the community here in the region. And so for today's presentation, I'm going to be sharing this stage with my colleague, named Frank, who is also the technical lead of the RMF 2.0 program that we're developing over in the Asia Pacific. So we're going to be sharing a little bit about there. I will share on the Asia Pacific initiative activities that we have been busy with over the last 1 year. And also, then I will pass it over to Lingfei to share about the RMF 2.0 program and where we are today with that development. All right, so just a little bit about the company and the organization that I'm from. So the ROS Industrial Consortium Asia Pacific is hosted by ASTAR. We are directly under the Ministry of Trade and Industry. Among ASTAR, there are a couple of research institutes. We're segregated by the Science and Engineering Research Council as well as the Biomedical Research Council. Where I'm from is from the Advanced Manufacturing and Technology Center. So we are focusing a lot of our developments in the area of advanced manufacturing applications. As an ARTC, we do organize ourselves within different industry verticals. We have 5 different industry pillars. We do have our consortium members as well. We have done a lot of R&D projects. So one of the key difference between us and the other research institute among our organization is that we focus a lot in the translational aspects of things. So we focus a lot more in the deployment and the development aspects of things and translating that into the industrial projects. So we work very closely with the industrial members as well to see how the technology can be implemented within the shop floor operations as well. So recently, I think some of the members that we have also achieved some lighthouse status that actually implemented the technology that we developed within our consortium. Sorry. Now a little bit about the ROS Industrial Consortium Asia Pacific that is hosted, which is also the place where we're from. So recently we have also grown the base of our members. So we have now about 20 over companies within our consortium. We do have a lot of research tier members right now. And the reason for that is because we are also ramping up on our training strategy over in the regions. We believe that we wanted to go closer even to the students and polytechnics and university people to allow them to know more about ROS before they get into the industries. We do have a couple of different new members as well within the consortium, a lot more technology partners, a lot more OEM. So we see this as a very encouraging trend that ROS is really gaining traction, especially in the Asia Pacific region. So with the Mitsubishi, for example, recently we also launched the new ROS-2 driver. So we collaborate together with them, and I think they have launched that last year during our annual meeting. So as a community, this is how we contribute to our ecosystem. We do a lot of ecosystem engagement. We put them together. We do focus technical project together with them. Talent development are very big, and the things that we're doing. In fact, I will share later how we inked an MOU with 7 IHLs over in Singapore, and how we are also now supporting the regional countries like Vietnam, for example, as well as Japan. We also do a lot of standardization and application developments, and this is really about how we advance some of the technology and capabilities to help facilitating the ROS packages and adoptions of ROS in the region. So really within the consortium itself, we segregate our capabilities and the core areas that we are working on in 4 different sectors. Our target verticals is in manufacturing, logistics, and facility management. So a lot of the things that we are working on are into these verticals. With regards to the core capabilities, we are focusing a lot in the ROS2 application development. So we do things from helping out creating the framework and the drivers, but also developing some additional ROS2 native applications. that really helps a lot of the actual use cases and putting ROS2 into the real industrial applications. So recently, we are also focusing our implementation development into developing this large-scale simulation design and development. So realize with regards to robotics, there's a lot of limitation when it comes to physical aspects of things. So we create this large world model where we can help to simulate a lot of the design of the robotics application before it's being implemented physically. They are natively ROS-based, so some of the things that we're working on can be implemented directly as well. And of course, we continue to support the advancements of the robotic middleware framework. So this is the interoperability standards that helps robot fleets to communicate to each other. So recently, in the past, it has been used to integrate and interoperate with the building infrastructure. Recently and later on, my colleague will share how we expand this for the manufacturing and logistics applications, which is a little bit different in terms of how it's actually being done, different frameworks, different system and enterprises they need to integrate in. And so we have spent at least the last 2 years now to enhance this part. And we have also recently developed this multi-agent AI platform for robotics deployment. So this multi-agent AI platform also leveraging on I guess compatible with some of the work that we are doing. So we realized that with the robotics application, we cannot develop everything all on our own. We wanted to make sure that even though they are being federated in terms of the learning, we're able to centralize the teaching, and therefore we are able to then deploy some of this application in a much accelerated manner. Later on, we'll also share a little bit about the snippets, how it's actually being done, and combining some of those things together. So these are some of the key initiatives that we have been very busy with. As you can see, a lot of the RMF implementation for facility management has actually gone into the industry. So besides the retail and commercial building, and a lot of them is already being put in fact, it's some of the tender in Singapore, individually, commercially. We also see schools, for example, leveraging on the robotic middleware framework, so we can actually utilize robots within the spaces. And we are also looking into the hotel operations. In fact, if you are coming to Singapore for the ROS-Con, you'll be able to see that live as well if you stay in one of the hotels. So that's a very encouraging trends that we see, that some of the work that we do here in urban source is actually being utilized in that industrial sectors. And as I mentioned earlier, we are also expanding the RMF reach into the logistics operations. In fact, we're working together with one of the Japan companies called RIC. They recently launched their first alpha version in September back in Japan. They have a whole blog written on what they're actually planning to do, what's their vision on the future of warehouse operations. And as you can see, we developed a very large-scale model here, and later on, Lisa will show a little bit more on that, and how this is being integrated together with that key platform that we have, digital twin simulation, to simulate some of the scenario planning, and later on it can be integrated back into the robotic middleware framework to really interoperate on a physical and sub-physical world. For this project, we're also working together, collaborative with AWS, so a lot of the inferencing is finally being done also on AWS. It actually helps to streamline a lot of the developmental effort and also help us with a lot of the compute requirements. And something that is very exciting for us is that on the initiatives with the RMF, we realized that we wanted to encourage more industrial adoptions, and one of those things is really creating this sandbox. So if you're in Singapore, we do have, and we are trying to see how we can actually extend this into the virtual world. But physically, we do have a space that is that's going to be launched later on this year in collaboration with PCA, which is actually the building construction authority in Singapore, as well as and funded by SMCPPO, to enable companies who wanted to leverage and test out RMF into the space. So we have a version that is working there. So if you want to test your compatibility to see how your robots actually interoperate with the building infrastructure, you can do so within the sandbox space as well. So I'm just going to skip this a little bit. So I'm just going to brush through. So this is the domain that we're touching on. So we do touch from components of system to the systems level. So this is the one that I mentioned earlier with regards to the talent development. So sometimes November 2023, we inked an MOU with 7 IHL in Singapore to help and support the proliferation of ROS into the students in polytechnic and universities. So starting from this year, we are running a pilot program, so students in university will be able to start studying and learning certain standards based on ROS. And so the whole idea is that once they actually graduate from the schools, they have at least a basic understanding of what ROS is and what's actually being expected by the industry. And so we've been working collaboratively with them, and if they're in one of these schools, they actually can enroll in one of them, and they'll be able to get that. One of the things that we're working on as well is we're doing this industry-centric assessment. So for those students that has gone through the training in one of the courses in one of our partners, we are launching a pilot assessment this year to sort of assess, right, what is the level of understanding. And the beauty of that is that once we actually have that, we're going to put them into some of the placement program. And I'm going to show you this platform that we are developing recently. So all of the students that has gone through this similar training can actually put their profile there, sort of like your LinkedIn, but for ROS Industrial. Okay. Yeah. So let me just play that out. How do I do this? I just like, okay. So you can see here, it has a list of all the different courses that you have, the platform and the next assessments that we're working on, companies, jobs, and different courses, who are the companies and the IHLs that we are partnering with, where people can actually get the courses from, what are the different programs, who should attend, what is this course going to look like, and finally, we'll be able to also see where you can actually find a job that is relevant to the particular training that you have already this thing. Okay, so yeah, so that will be the last slide, and I think before I pass it over to Link Fred to talk and share a little bit about the RMF 2.0 program, a little shout out that like Matt mentioned, we're going to be doing ROS-I in Singapore this year, right? So we're very excited to have that. It will be on the 22nd October, so we have a full lineup of the things that we're going to be showcasing from the robotics community over in Singapore as well. So if you're down, you're coming to Singapore, you'll be able to see a lot of robotics application across the entire country, from retail facilities, and we're planning to also do a tour to some of the factory operations to see the robot being utilized there live. So we're very excited, so we're looking forward to welcome each and every one of you to sunny Singapore. Okay. Yeah.
Okay. Hi. Oh, wait. Let me just adjust this for you. Hi, everyone. So, yep, I'm Ling Fei. I'm a technical lead at ROS-I. So, I've been working on the RMF 2.0 program for the past 2 years. So, yep, I think before I talk more about RMF 2.0, I just want to give an overview of RMF 1. Basically, maybe Singapore's RMF journey and how we arrived at RMF 2.0 2 years ago. So actually, RMF, or Robotics Middleware Framework, was a collaboration between previously Open Robotics. So now I think it's part of Intrinsic, as well as NRP, so National Robotics Program in Singapore. So at that point of time, in I think around 2018, RMF was developed as a interoperable framework for mobile robots in hospitals. So as you can see here, on the first thing on the left, so we have the CGH and chart. So there was a physical demonstration in the healthcare lab in the Changi Airport. The Changi Hospital in Singapore. At the same time, in 2018, ROS Industrial was also doing some simulation demonstrations for highly congested environments. After RMF 1 was developed by Open Robotics, over here at ROS Industrial, we took some R&D initiatives to adapt RMF baseline for manufacturing, I think almost 5 years ago. So we had the RMF focused technical project where we did some developments for manufacturing to include work cells, sensor integration, and new tasks. So this was all the way back in 2018. And moving on forward a few years, we have a few companies in Singapore that took on RMF and then integrated it into their fleet management system. So we have companies such as NCS, Robot Manager, as well as the Hope Techniques Beacon. At the same time, we were also collaborating with the Changi Airport Group in Singapore to bring over mobile robots that were integrated with RMF. So these included things such as cleaning, as well as maybe patrolling tasks inside the robot, inside the airport. At the same time, we also had deployments in the Tampines Regional Hub, inside a library where I think there were some mobile robots moving in RMF. So moving on towards maybe 2022, 2023, we also did additional projects in RMF to bring additional features on top of RMF1. So at ROS Industrial, we added the additional scheduling capabilities for RMF1, and we did the CAG phase 3. Actually, it says here that the expected completion was November 2023, but then we finished it last year. And I think as of now, there are some cleaning robots that are actually deployed at the airport in the Changi Airport Group, and I think they're running on RMF. So, 2023 was where we were at. And at that point of time, over at ROS Industrial, we wanted to look at how to bring interoperable robotics into the manufacturing and logistics space. So this was our main motivation 2 years ago. We really wanted to be able to better enable integration, interoperation, and orchestration of heterogeneous mobile robot fleets and enterprise IT and OT systems. So when we developed and came up with interoperable robotics for manufacturing and logistics, we split it into 3 main work packages. The first one was on integrative dynamic co-simulation for digital twin-based scenario planning and performance optimization. So here, we mostly focused on scheduling capabilities. So we wanted to have a certainty in the production's schedule execution. We wanted to be able to detect and eliminate bottlenecks, be able to plan our tasks such that we could do optimal utilization of AMR resources, and we wanted operational data-based scenario planning and optimization. So we really wanted to collect the data from the warehouse and then use that to help our scheduling and planning capabilities. Next, we also wanted to look at basically in the warehouses of the future, how we could build up a framework or a system that could enable hyper connectivity for enterprise IT/OT integration in manufacturing and logistics. So what we hope to achieve here was to have a seamless integration of IT/OT systems, be able to come up with a standard of a unified data structure and unambiguous semantics across systems and applications, such as warehouse operators, they could bring in any of their maybe hardwares and software and be able to integrate into our system. We wanted to also achieve an elimination of islands of automation, data, and analytics. So the next work package that we were looking at was the robot execution system for autonomous manufacturing value chain. So what we really looked at here was an optimized execution of schedules by AMR. So inside warehouses, we predicted that, not say we predicted, but what we learned was that they could have up to 100 or 1,000 AMRs. So we needed to look at how we could do an optimized execution of tasks for these AMRs at the same time. We wanted to have an agility in accommodating operation dynamics, learning-based continuous optimization of the tasks by the robots, and a control tower of AMRs and related operations. Also, of course, inside warehouses, we will need to do some work cell integration to enable configurable manufacturing robot-based workflows. Okay, so next, this was the system architecture that for RMF 2.0 that we proposed that would work, that we wanted to achieve. So, but mostly if you look at let me see if I can get my Mostly the blue modules are what we envision the RMF 2.0 modules to be, and the green modules are actually points of integration that we imagine with the warehouses. So as you can see from the right, we have the discrete event simulation. So this part was really more of the planning and the simulation part, where we hope to take tasks from the robot task scheduler, run it through the discrete event simulation together with a on-demand co-simulation bridge that connected to a physics-based simulation here on the bottom right. What we hope to do here is to ensure that the task could be run in a simulation first before being brought back to the task scheduler as an optimized task sequence. On the top, RMF 2.0 hope to build a robot task generator that could connect to any MES or WMS to generate mobile robot tasks that could be fed to the robot task scheduler to be optimized and then sent down to the task orchestrator. For the RMF 2.0 framework, we hope to build work with a cloud-based system where we could put the software services on the cloud. So this included services such as a push event notification service or the multi-agent pathfinding execution service that we envisioned for the system, and then the task orchestrator could then send down these tasks to the devices on the edge. This whole robot execution system would be supported by a context broker with a data lake that could support the amount of data that was flowing inside the system. With this architecture, we looked at how to really go on to achieve at least a base level of industry adoption. So what we started here was RMF 2.0 for warehouse applications. Our problem statement that we were given at the start was to be able to develop an end-to-end solution that could realize warehouses of the future where a large scale of heterogeneous robot fleets could communicate seamlessly with each other on the edge as well as cloud services on the cloud. So when we looked at their problem statement, we realized that actually the RMF 2.0 framework that we could get, actually, if you look here, this is actually a simplified version of what I showed you in the previous slide. So what we realized was that this could be achieved with our current framework, and we set out to achieve a very, at least a simple version of it initially by integrating some of the core modules in RMF2, such as the robot task generator, the task orchestrator, and the robot execution system, being able to call on the RMF 2.0 side, the multi-agent pathfinding service on the cloud. On the RMF 2.0 on the edge, we implemented a VDA 50/50 connector in simulation to be able to connect with VDA 50/50 robots on the edge. The key features that we aim to achieve were to have interoperable services and tasks, standardized communication protocol, and a large-scale coordination of mobile robots. What we really wanted to have was to have an easy and open framework to encourage the development of software services. The key outcomes that we hope to achieve from this project, and I'll show you a quick demonstration of it, a quick video demonstration of it later, was that we wanted to have an integrated cyber physical large-scale simulation. So actually with this large-scale simulation, we were really able to bring forward development a lot because we were able to test and run a lot of our code inside a physics-based simulation that could run in real time. And with the large number of mobile robots, we could really test and ensure that our code was running well. The next key outcome we had was to be able to have a customized task flow handling. Because the customer, they had many different, very complex use cases, we needed to design a framework that could handle their customized tasks. And of course, with the large amount of robots that they had, we needed to achieve a large scale orchestration of mobile robot fleets. Okay, so here I will just show a quick video of what we have done for a simulated warehouse with RMF2 integration. So you can see here that these mobile robots, we have built VDA 50/50 compatible clients for them to run. We have also actually built VDA 50/50 clients in the physical space as well, but those are with a smaller smaller number of robots. So we wanted to show you that these robots are actually, they're running and they're all being centrally controlled at the same time. They're running a multi-agent pathfinding algorithm, and then we also further optimized on the multi-agent pathfinding algorithm by implementing some of our action dependency graph execution for these multi-agent pathfinding. So at the same time, we also, because this is a large warehouse, we have also been able to collect the data and then run it through some of our other use cases that I think Maria was talking in the past just now about Cube and AI and these kind of applications. Yep, actually, I think I'll just let this run for a while. Okay, so I think I've come to the end of my presentation. If we have any questions, I think we can have some time for questions.
Excellent, thank you. Any questions for Maria or Ren? Make sure you repeat the question.
Okay, yes.
What are you using for generating the tasks?
Okay, so the question was what are we using for generating of the task? So actually, if I bring you here, we have built our own robot task generator that's able to connect to the MES and then generate a robot task that can be scheduled by the robot task scheduler within the RMF 2.0 framework. Thank you.
So did you build your own simulation engine?
So we didn't build our own simulation engine, but we actually this is built based on the Unreal Engine 5, but we built our own simulation environment, and we found that building the environment was really crucial for us because inside the warehouse, when we were able to simulate a large number of physics-based robots, it was able to accelerate our development on the software stack.
So using actually the simulation environment is agnostic. So this one is actually agnostic. So we designed in such a manner that if customer wanted to use, like let's say Omniverse, Unreal Engine, or any other simulation tool, we're able to port the exact same thing. Yeah.
Excellent. I would like to also, so we've had some questions here in the States. I don't see Paul immediately, right? But there's been some interest in potentially like running pilot programs here in Americas on Open RMF. Can you talk about a little bit of the availability of RMF 2.0 versus Open RMF? Like, I guess it's still called 1.0. Can you add some clarity to this situation we're at now?
Sure. I think if you look into the architecture earlier, we're striving to make it back compatible. But with the RMF 1.0, the original intent was really to utilize that for facility management side of the things. So we have utilized it with some success as well. What we are actually extending with the RMF 2.0 so that it can actually be adapted for enterprise systems where typically manufacturing and logistics sectors will require that. So that's, I think, the major difference of that. So really depending on like the verticals that we're looking at, then we can actually sort of see how we can implement that factor. So it's not so much about like non-compatibility between the RMF 1.0 and 2.0. I think predominantly we're extending that capabilities to see how it can be utilized for that verticals as well.
Right. So like hence the MES. And
exactly. Yeah. So
enterprise.
it's after integration.
Yeah. I can bring it.
Hi, my name is Yadu from Intrinsic. Thank you for the presentation. So I'm curious to see, or I'm surprised to see the choice of integrating with VDA 5050, because when we started building Open RMF at Open Robotics back in 2018, there was no such spec that existed, and RMF was meant to be the spec for interoperability in mobile robots. So did you find that the VDA 5050 is more comprehensive and therefore you want to adapt RMF 2.0 to that? Or could you see opportunities to improve the Open RMF spec to meet your requirements?
Okay.
So I can answer that.
Yeah, no, actually the reason why we wanted to extend that is that we wanted to just give more options, especially because we are trying to get into warehouse automation. We realized that VDA 5050 are more pervasive for that particular verticals. So that's the reason why we are creating that additional adapters, that's all.
Thank you.
Oh, yes.
Yes,
good.
I can bring it to you, Ryan. Oh, you have a question in front.
Yeah, so in the simulation, I also see robot arms in there. So is that also integrated with IMF 2.0?
Yes, so the architecture behind whatever that you see there, it's based on these architectures as well. So yeah.
Okay.
Right, but it's actually not necessarily driving the manipulator arms. It's actually just it's more of the state.
Correct. Yeah, it's just
So like, obviously you can say like, hey, no manipulator's here, robot do your thing, robot says it's done, right?
So the whole idea is that when we build that simulation is that we can actually go zoom in and zoom out as well. But for that particular application, it was just a state. But in the future, if we wanted to add that element, it was created with that in mind for scalability.